Hey, Algebra 2, going over the practice tests. Remember, this is the one I assigned on Wednesday, so this is number 1, the first one I gave to you. So that's what I'm going through. And you'll be able to tell if this says 3 times sine of theta on the top, then you know that this is the first worksheet that we're working on. Okay, so you just got to match up the problems to make sure you're following along on the right one. But again, the second practice test that you're going to get on Friday is going to be the same thing. It's just going to have different problems. It's still going to be structured the same way, same problems, just different numbers. Okay, so moving on. So starting with number 1, we want to first of all use radians. So everything is going to be in radians. As you can see up here on the x-axis, you have pi over 2, pi, 3 pi over 2, 2 pi, and so on. And then we need to find the amplitude and the period of each function and then graph it. Okay, so for the first thing I'm going to do is find the amplitude. I'm going to call that A. And you simply find that from looking at the first number in front of your function, which is 3. So the amplitude is 3. So that means that when you graph it, when you start in the center of the graph, the top and the bottom will be 3 units away. Okay, and the period is how long will it take for this graph to repeat itself or to complete one cycle. And you find that by going in here next to the theta, and there's no number there, so it's just 1. And if it's 1, then the period is just simply 2 pi. So it takes 2 pi is how long it takes to complete one whole cycle. Okay? So again, if there's nothing here, it's just 2 pi. If it's a different number, let's say if it was 2, then you would do 2 pi divided by whatever that number is. So here it would be 2 pi divided by 2, and then the period would be pi. Okay? But in this case, and in all the cases on the test, honestly, it's just going to be 2 pi. Okay, now remember with sine, sine starts in the middle. Okay, so we're going to start right here at the origin. Then sine goes up. At pi over 2, it goes up to 1. Then it comes back down to the middle. Then it goes down below at 3 pi over 2, down to -1, and then comes back up to the middle again. Okay, so the regular sine graph looks like this. Okay, and it keeps repeating itself over and over again. Okay. Okay, but our graph is going to be different because it has this 3 in the front of it. That changes the amplitude. So instead of our graph going up to 1, it's going to go up to 3. But it still will come back to the middle. But then what changes again is it will go down, let's use green actually, it will go down to -3 instead of down to -1 and still come back to the middle. So now our graph should look like this. And it'll continue to repeat itself. And if you notice where I stopped right here, this is one complete cycle. It goes up, comes down, then goes back up. Then it goes up, comes down, then goes back up. And it keeps on going. I'm going to go ahead and continue it as far as I can. Okay? So there's the sine graph. Now for the second one, you've got a couple changes going on. You've got this 4 here, and you've got a +1 out here. So first, the amplitude, just the number in front of cosine, which is 4. Okay, and then the period, well, there's nothing in front of the theta, so it's just 2 pi. Okay, now cosine is different than sine in that sine starts in the middle, whereas cosine starts above at 1. So it starts up top. And then when it comes down to pi over 2, it comes back to the middle. And then it follows the same pattern of sine, except it starts somewhere else. So now it goes back down to 1, and it comes back up to 3 pi over 2 in the middle, and then at 2 pi it comes back up to 1 again. So then it would look something like this. If I kind of do a quick little dash, something like that. But it's going to change because of these two numbers. So the first change is that the amplitude is 4. So instead of going up to 1, it's going to go up to 4 now. And then it's still going to come back down to the middle, just like before. But now from the middle, it's going to go down, not to -1, but to -4. And then back up to the middle again. And then not up to 1, but back up to 4. Okay, so then it would look something like this. Okay, but again, now we need to change it again because it has +1. So remember, the number on the outside, if it's added, it's going to shift up. If it's subtracted, it's going to shift down. Here it's +1, so all our points are going to shift up 1. So then this point in the middle is going to shift up 1. This point down here is going to shift up 1. This point here shift up 1. This point here shift up 1. So our final graph will look something like this. Oops, I didn't make it through that point, did I? So I'll go down here, pass through this point, and then pass through this point, and then it just keeps going. So it's almost like our middle axis here, which was the x-axis, has shifted up. So now we have this new axis here. And that's our new middle of the graph. And so we use that as kind of a reference point. It keeps on going. Okay? Okay, now the next one. Okay, so now using radians, find the amplitude, vertical shift, and period. Amplitude, vertical shift, and period. So all we're given this time is an equation. So for amplitude, again, it's just the number that's in the front. So A equals 8. Okay, there's our amplitude. Now vertical shift. I'll just put VS. Vertical shift, again, comes from the number on the outside, so it's 2, or +2. And then the period, again, you look at the number here. If there is one in front of theta, and there isn't, it's just 2 pi. Okay, over here, amplitude is 3. Vertical shift, I look out here, so it's -5, so that means it goes down 5 or -5. And then the period, again, there's no number here, so it's just 2 pi. Okay. Now for each sequence on this next one, state if it is arithmetic, geometric, or neither. So what you need to do is you need to test out a couple things. First, you want to see if there's a ratio, so find a ratio, and then see if there is a difference. Okay, so first, let's see if there's a ratio. So 10 over 18, that reduces down to 5 over 9. And then 6 over 10, that reduces down to 3 over 5. Well, right away I notice that's not constant, because it would be the same every time. Okay? So those aren't constant, so it's not a ratio, so meaning it's not geometric in this case. It's not geometric, so maybe it's arithmetic, but I still need to check. So to find if whether it's arithmetic is find the difference between each number. So the difference in for the first two numbers is -8, because it's going down, so -8. Then here it's -4, then here it's -2, and that's not constant either. So that means it's neither geometric or arithmetic, so it's neither. Okay. And number 6, again, do the same thing. First, see if you can find a ratio. So I'm going to do -5 over 3 divided by 5. Now we're dividing a number into a fraction, so that means I'm going to need to flip the second number. So I'll flip it, and now it becomes 1 over 5, and no longer division, but now multiplication. So now multiply across, -5 over 15, which reduces down to -1/3. And then let's check the next pair and see if we have a pattern. So now 5/9 divided by the previous number. Remember, you always divide by the number before. And again, in order to divide, I have to flip the second one. So now 5 over 9 times, remember it changes to multiplication, -3 over 5. So now we have -15 on the top and 45 on the bottom. And this also reduces down to 1/3. So we do have a constant ratio. That means it's going to be geometric. Okay. And if this wasn't constant, if it wasn't 1/3, then I would try to find the difference and see if that works. And some of you guys might already see the pattern. You might say, oh, wait, all we're doing is multiplying the denominator by -3 each time, and that's what's happening. You might see that right away, or you can just find the ratio like I did. Okay, now here, see if you can find a ratio. I know, some of you guys already see the answer, I know. Okay, well that doesn't reduce down. And neither does this, and those aren't the same. Okay, but some of you guys already saw that, oh wait, the difference is +10 each time. So if the difference is the same, then we know that it's arithmetic. Hey Eduardo, ¿cómo estás? Okay, so now on number 8, again, you could start with the difference if you want. You don't have to start with the ratio. Actually, let's start with the difference first. So the difference here, looks like we're getting bigger, so we're adding. Looks like it's adding 8 here. Here we're adding 4. Here we're adding 2, so it's not arithmetic. Okay, so let's try the ratio. Okay, so this reduces to 3/7. Okay, and then, oops, sorry. And then we have -2/6, and that reduces down to 1/3. So that's also not geometric. So this one is also neither, because it has neither a ratio or a difference. Okay, so now let's go on down to the next page. Number 9. So it says find the first 4 terms in the sequence. Well, it's pretty simple. I know I got to find A1, A2, A3, and A4. Okay, and then I'm going to use this formula to find each term. So if I want to know term 1, I use this formula and I plug in 1. Okay, so then -18 plus 2, because 2 times 1 is 2, is -16. Okay, and I do the same thing all the way across. So -18 plus 2 times 2, because I'm looking for the second term. So now it's going to be -18 plus 2 times 2, which is 4. That gives us -14. And then -18 times 2 times 3. So that's going to be -12. And if you notice, it's increasing by 2. And the reason it is because you have the rate of change, or the difference, is 2. So then I don't really have to calculate the next number. I know the next number is going to be 10. So if you notice in the arithmetic sequence here, if you notice the difference, that it's 2, it's 3, whatever it is, then you can either just add or subtract that to find the next term. So find the first one and then just add or subtract to find the next one. And I'll do that here. Or if we can, as long as it's not too complicated. Sometimes the formula might be too complicated for us to even figure it out. Okay, so 218, I want to know the first term. So plug in 1. So really it's just 218 minus 200, which is 18. Okay, and then for term 2, well, this is going down by 200, right? So I think I'll just go ahead and do the math here. Okay, so 218 minus 2 times 200 is 400. So that means we're going to have, let's see, minus 200. That will be, let's do this on calculator real quick. Uh-oh, whoops. Yeah, so sometimes it's not as obvious. And some of you guys might be able to see it. You're smarter than I am, right? So, calculator. So I'll Google calculator. So 218 minus 400, negative 182. Okay, and then the next one, 218 minus 200 times 3. Oops, sorry. Okay, so now clear that. 218 minus 600 this time. Negative 382. Okay, and then I know my next term is going to go down another 200, so that would be negative 582. Okay, so there's my terms. Okay, number 11. Okay, now number 11, it's a little different than what you saw before. So here, my variable was n. Here, my variable is this a, with this little n minus 1 on the bottom. Remember, we call this a subscript if it's on the bottom there. All right, this is the one before is an explicit formula. This is recursive. Remember, recursive means that I have to know the number before in order to find the next term. So that's why they give us the first term. So I have to start with finding A2. And to find A2, or the second term, I plug in 35 to this variable here. Okay, you're not plugging in two numbers. You're not plugging anything to that n. That's just a label. Okay, you don't, and the only time you plug anything to this n minus 1 would be if it's in the exponent, but it's not. It's down here. So now we just simply plug in 35 minus 8. That gives us 27. And then for the second term, or I meant the third term, we take the 27 and plug it in, and now it's 27 minus 8, and that gives us 19. And then to find the last term, or the fourth term, we take the 19 and we plug it in, and then subtract 8. Okay, and that would be 11. Or you can simply just realize, okay, well, I'm subtracting 8 every time, so it's going to be this minus 8, then 27 minus 8, then this minus 8, then this minus 8. Okay, you can follow that pattern as well. Okay, this one's going to be the same one. Okay, so I know the first one's going to be 27 plus 10. And then I'm adding 10 every time to the number before. So now 37 plus 10, 47. And then 47 plus 10. Okay? So just remember, to find the next one, all I was doing was adding the previous term. So in other words, this 47 came from 37 plus 10, and this 57 came from 47 plus 10. Okay? Alright, move on. Now we got to find the explicit formula. So again, for both of these, remember you're going to use this formula, a sub n equals a1 plus n minus 1 times d. And you just need to plug in the missing terms. So to find the formula, we need to know a1 and the difference. And we want n to stay free. We don't want it to plug in anything there, because we need a variable. So we start with an. First term is negative 25 plus n minus 1 times the difference. Okay, well, you'll have to find the difference. And it looks like it's decreasing. It's going down because it's getting more and more negative. So that means we're subtracting 3. Subtracting 3, subtracting 3, so there's my difference. Okay, or you could just do negative 28 and subtract negative 25, and you'll get the same thing. So now an equals negative 25, and then distribute the 3 here and here. 3n plus 3, because it's negative times the negative. Now combine the like terms. Negative 25 and 3, but first I'm going to write the negative 3n, and I'll combine negative 25 plus 3. That's going to give me negative 22. There's my formula. And that's all we needed. We just need that formula. Okay. I'll let you guys go ahead and try that one on your own. Use the formula, plug in the first term, find the difference. Okay? Okay, now this one. I went over this in class. This is a little bit different than what you guys have seen before. You're still using the explicit formula for arithmetic sequence, and it's that an, same one I just wrote, equals a plus 1 plus, sorry, not a plus 1, a1 plus n minus 1 times d. Okay, so in order to find the 29th term, I'm going to need to know a1 and the difference, and then I can just plug in my values. Okay, because I don't have a formula to find it. I don't know what the difference is. I don't know what the first term is, so I don't really know how to find the 29th term until I find these values. Okay, the A1 and the difference. So the first thing I'm going to do is look for the difference. Okay, so we're going to find the difference over here. We're going to find D. And to do that, I'm going to change this equation around just a little bit because we're not given the first term. But what I'm going to do is treat this 1,775 like it is the first term. Okay? So instead of A1, I'll say AM, and that's going to be our first term, AM. Okay? And now, this will still be N, but now I'm not going to subtract 1, because usually this is 1. If this is 1, I subtract 1. I'm going to actually subtract the M. Okay, whatever that number is. In this case, it's 19. And I'm still going to multiply the difference. So now I'm going to plug in my values. Because now this is our last number, or the other term, AN. So I'm going to plug that in there. So I'm going to do that over here. So now 3675. So again, what I'm doing is I'm using this formula here. And remember, all I did was I changed the A1 to be this first term here. Or basically we're treating that 1775 like it's the first. And then I also changed the 1 to this term, or this number here, the 19. And I'm just going to call it M. Okay? So now it equals, okay, AM, which is 1775, plus N minus 1. Well, N is 38, because 3675 is the 38th term. And then the M is the first term given, okay, the 19. So then we'll subtract 19 from that. Okay, and then we have D, and that's what we're going to solve for. So now, what I'll do is at the same time I combine what's inside the parentheses, I'm going to subtract the 1775 from both sides. Just going to do it all at the same time. Okay, and what I'll get here, let's do that here, 3675 minus 1775, 1900. Equal to 38 minus 19 is 19, so 19 times D, and then divide both sides by 19. So then our difference is 100, 1900 divided by 19. Okay, but in order to, again, find this term, I need to know the first term now. So now that I know the difference, I can find the first term. So now I'm going to find A1. Okay, so to find A1, I plug in what I know, take one of my terms that I'm given, 3675, and I'm looking for this term, A1. So it's going to be plus N minus 1, but remember N in this case is 38 because we're using 3675, subtract 1, and then times the difference, which we just found. Okay, so now 3675 equals A1, and then simplify all this. This would be 38 minus 1, which would be 37. Then 37 minus 100 is 3700. Subtract that from both sides. You're doing the same math, you're just doing it a couple different times. Okay, and I end up with negative 25. Now I have D, now I have A1, so just plug it all in. So now the 29th term is going to be equal to A1, which is negative 25, plus N, which is in this case 29, because we're looking for the 29th term, minus 1, times 100. Okay, so now 25 plus, well, 29 minus 1 is 28. 28 minus times 100 is 2800. And so 2800, or negative 25 plus 2800, well, that would be 2775. And there's our last term. And you're going to treat the second one the same way. And I'll actually go over that, kind of the first steps there, and especially how to set up the first step in finding the difference. Okay, so let me keep this kind of zoomed out so we can see the other problem. And let's make kind of a little bit of a divider here. Okay, so first let's find d over here. Okay, so what I'm going to do is I'm going to take this last term, use the same idea over here, and change that. I'm not going to use a1, I'm going to use am, which is the first term given. Okay, so I'm going to plug in the negative 252, just like I plugged in the 3675 over here. And I'm plugging this negative 72 here, sorry, plus n still. This is still n, so the n here in this case is 40, because we're going to treat this term like it's an, and this term like it's am, and it's 40 minus 10, because negative 72 is the 10th term, and then times d. Okay, and then we simplify. Negative 72, 40 minus 10 is 30, so then plus 30d. Now we're going to add 72 to both sides in order to get rid of it, because it's negative. Cancels out. Let's see here. This would be 180. Yeah, negative 180. Okay. Equals 30d. Divide both sides by 30. Cancel out and isolate d. And then we get negative 6. Okay, so there's our difference. And then we go ahead and plug in that d back into the equation here, and then use one of the terms to find a1. And then go ahead and plug in a1 and d back into the formula, and then that will give us the 26th term. Okay? So now let's go down here. Now we got to find the arithmetic series described. Alright? Well, I got to find this. If you see the sigma notation, that means we're going to find the sum of a series. So that means I'm going to be using the equation that has Sn in front of it. The question is, which one am I going to use? Am I going to use the geometric or the arithmetic? Well, guess what? It says arithmetic. So use the arithmetic one. And that one is the n over 2 times a1 plus an. Okay, so I need to find the number of terms, the first term, and the last term in their sequence, or series. So let's plug in what we do know. I know n because it starts at 1, ends at 11, so that means it's going to be 11 terms. So S is 11, S11 equals 11 over 2. But I don't know the first and the last term. I'll have to find that using the formula here that's in the notation. Okay, so to find the first term, I plug in whatever this number is here at the bottom. So it's 1 in this case. 10 times 1, then subtract 2. Well, that's just going to be 8. So there's our first number. And then the last number is the 11th term, so I plug in 11. So 10 times 11 is 110. Minus 2 is 108. So now add 108. And let's do the math. Okay, so now 108 plus that is 116. And let's see, let's simplify. So I'm going to divide the 116 by 2. So now it's going to be 58. And then 58 times 11 . 638. And there's my sum for that series. Okay, so then this one's a little bit different, still the same types of steps. So I take my sum of a series formula, and the total terms, that's the question. Well, it starts at 4 and goes all the way to 17. So how many do I have to add to get to 17? Or to get to 17? I'd added 13, right? But then we also need to include the 4. Okay? Because it's just like this. How many terms would it take to get from 1 to 11? Well, 10. But we also include the 1. Okay, so here it would take 13, but then we also include the 4. Okay, so 14. So S14 is equal to 14 over 2. That's our n. And now to find the first term. First term, well, they're using the fourth term as the beginning of their sequence. So you're not going to plug in 1 like we did here. You're actually going to plug in the 4. Okay, so whatever the number is here on the bottom, that's the one you want to plug in first. And that will tell you your initial term. Okay, so we have 9 times 4, which is 36, minus 4 is 32. And then we also need, okay, so then we'll go ahead and plug that in. 32 plus, and then we need the last term, the an. And so what we do is we take that 17 that's on the top, and that will be our last term that we plug in. So plug in 17 minus 4. And let's go ahead and do that in the calculator. 17. So 9 times 17. But then it's also minus 4. So 153 minus this 4 would be 149. So 149. Okay. And let's simplify that a little bit. Well, 14 over 2 is 7. Okay, 32 plus 49, that's going to be 179 plus 2, so 181. And now, multiply that out. That'll give us our answer. So 7 times, not divide. 7 times 181 is 1,267, or 1,267. And there's our sum for the second series. Okay. Now, this one here. Find the 3 terms in the sequence after this one. Well, this is pretty simple. You just find the next 3 terms. Well, I recognize here right away that this is being more multiplying 2 here. And if you didn't know, then you could simply just divide the next term by the previous term. So I could do 2 over 1, well, that's 2, then 4 over 2, that's 2, and then I know I'm multiplying 2 every time. Okay, so the next one would be 16, multiply 2 again, 32, multiply 2 again, 64. Okay, here, let's use the ratio. And just right away, I'm thinking it's a ratio, or we're multiplying something. So 18 divided by 3 is 6. 108 divided by 18. I gotta check that. 108. 108 divided 18, 6. Okay, so we know the ratio is 6 for sure there. So I multiply 6 here. Then my next term, that's obviously not very obvious. Let me use the other calculator on here. Oh, can't use that one, sorry. So we'll do 648 times 6, 3,888. 3,888. And we're going to have to multiply, again. Sorry about that. So that times 6. So 23,328. 23,328. And obviously, if we're separating by commas, you're going to be careful. So I'm actually not going to do a comma because I don't want to get confused, especially on the test. If you put this and then comma, I'm not sure if you mean 23 or did you mean something else. Okay, to get our last term, multiply 6. So actually, let's take that previous answer. Actually, I think I can actually just press answer here, and that will multiply it times that number up there. Times 6. Yeah, there we go. 139,968. So 139,000. What's it again? I missed it. Oh, 968. Okay. Oops. Too far. 968. Okay. So there's my 3 terms there. And that's all you do for those 2. Now here, find the explicit formula. Alright, well we've done this before, except now it's not adding, obviously. Looks like it's doing something else, probably multiplying or dividing a number. Okay, so What I need to do here is I'm going to use the geometric explicit formula, and that is a1 times r to the n minus 1. Okay, well what I need is I need to know the first term, a1, and then I need to know the r, the ratio. Okay, so really, I already know the first term, because here it's -3 and here -2. So really I just have to find the ratio. And I'll set up, that will finish finding the formula. So to find the ratio, I'm just going to do the next term divided by the previous. So that's 4. So we know the ratio is 4. So now, simply just this. an equals the first term, -3, times the ratio 4 raised to the n minus 1. Okay? Same thing here. Do 6 divided by the previous number. So that gives us -3. And the first term is -2. So a sub n equals -2, which is the a1, times our ratio, which is -3, raised to the n minus 1. Okay? Now, in this one, you're given two terms. So this a1 and this other term. In a geometric sequence, find the common ratio and the term. Okay, so we're going to use this formula again. a1 times r to the n minus 1. And the first thing we're going to do is find the r. We don't know what the ratio is. We know the first term and then some other term. So what we need to do is find the r first. So I'm going to take what I do know, this 64. I'm going to plug it in for an. I know the first term, they give it to us, so I'll plug that in there. But I don't know r. And then what I plug in for n is whatever term this is. Okay, so if I plug in 64, that's the sixth term, so n is 6. 6 minus 1. Now let's just simplify what we got so far. The 6 minus 1 is 5. Then we want to isolate r, so divide by -2 both sides. So I get -32, and then equals r to the fifth. Now in order to get r isolated by itself, I'm going to put these under a radical, and the index I'm going to use is 5, because that will cancel out this power of 5 here. So if I raise it to the 5, then that will cancel it out. And if I plug that into a calculator, the fifth root of -32 is -2. Because if I multiply -2 5 times, that will give me -32. So now I just take my formula, and I want to find the 10th term. So I plug in the first term times, now I know the ratio. That was the first part. And I multiply -2 times the ratio, -2, raised to 10 minus 1, or n minus 1. Okay, so now it's -2 times -2 raised to the 9th. So I'm probably going to use the calculator for this one, because I don't know what -2 to the 9th is. Okay, so let's do -2 parentheses, -2 parentheses, raised to the 9th, 1024. Okay, so a sub 10 is equal to 1024. Okay, and you do the same thing here. Okay, first we've got to find r, so I'm going to plug in what I do know. 64 equals, I know the first term as well, so -1 times r, which we don't know, raised to the 4 minus 1, because that 64 is the, or -64 is the fourth term. Simplify. 4 minus 3. I'm sorry, 4 minus 1 is 3. Divide both sides by -1 to get rid of that -1. And isolate that r. Okay, so these negatives will cancel out. Positive 64 equals r to the 3. And since it's r to the cubed, I'm going to take the cube root. And the cube root, I happen to know, is 4, because 4 times 4 times 4 is 64. And then I want to know term 9, so a9 is going to be equal to -1, which basically -1. Oops. times the ratio, or r, which is 4, raised to the 9 minus 1, because we're looking for the ninth term. So we get negative 1 times 4 to the 8th. Okay, let's plug that in. So now 4 to the 8th, so negative 1 times 4, oops, not that, 4 raised to the 8th. So negative 65,536. Oops, I don't know where my problems went. So then term 9 is negative 65,000. Sorry, 536. Okay, and that was my answer for the last problem. Okay, so now evaluate each geometric series described. Okay, this is whenever you see the sigma, that means we're looking for a sum. Okay, so here we're going to use the sum formula for a geometric series. If we go back here, we were finding the sum of an arithmetic series. Okay, and you can tell it's arithmetic because it's just some number times a letter. Okay, and then here you'll see a variable in the exponent, so you know it's geometric. Okay, and that one is a1 times 1 minus r to the n over 1 minus r. Okay, so what we need to know is a1, the first term. We need to know r, the ratio, and we need to know n, the number of terms. So let's go over here to our formula, or our sigma notation, and figure out what all those are. Let's start with a1. Well, a1 is given by this number here in the front, negative 3. That's our first term. Then the r is given by the next number, the 2. And then the number of terms, n, well, if we start at 1 and go to 8, that's a total of 8 terms. So now we can simply just plug in all those numbers. So now s of 8, or s sub 8, is equal to a1 is negative 3, 1 minus r, which is 2, raised to the n, which is 8, all over 1 minus r, which is again 2. Okay, so now let's simplify this a little bit as much as I can. Okay, so negative 3 times 1 minus 2 to the 8th. I don't know what 2 to the 8th is right off the top of my head. And then 1 minus 2 is negative 1. Okay, so I know that these negatives will cancel out. So then I'll just have positive 3 times 1. I'm simplifying it just because I want to make it easy to put in the calculator. 1 minus 2 to the 8th. Okay, so let me put that in. Oops, sorry. So now 3 times 1 minus 2 raised, wrong key, raised to the 8th. Negative 765. So then S8 is equal to negative 765. Okay. Okay, now the next one. Again, we know that the first term, A1, is 4. That comes from this number. Then the R is again 4. Comes from the next number. And then the number of terms is from 1 to 7, so 7 total terms. So then we're going to do S of 7 equals A1, 4, times 1 minus R, which is 4, raised to the 7, over 1 minus R, which is 4. Okay, so then we get 4 to the 7th over 1 minus 4, which is negative 3. And so I'll just punch all that in. Okay, so now 4, where's that? 4 times 1 minus 4 raised to the 7th parentheses. So let's figure out what that is, and then divide that by 3. So negative 21,844. So S7 equals negative 21,844. There's our answer. Now when you guys do this, if all you write is this, basically setting up the problem, and then you write in the answer, I'm okay with that. Okay? You don't have to write these out identified on the left, write out the terms. You don't have to show the work unless you want to. I'm totally fine with that. I want to see that you set it up correctly. So don't just try to punch this in the calculator, which you can, and you can use that to check it if you want. But I want to see you actually set this up with the sum of series equation. Okay? So now this last part, guess what? I didn't teach it to you, so I'm not going to have you guys do it on the test. Okay? All right? Hush, don't tell Mr. Kershaw's class. All right, so that's it. Got any questions? You can hit me up on Remind. Coming early on Monday. Have a good weekend, guys. Bye.